Okay, this is Professor Terry Clark. I would like to welcome everyone to our go-to training today. Today we're going to be reviewing for the final exam. Can everybody hear me loud and clear? And can everybody see my screen? Okay, great. Everybody is saying they can hear me. Okay, now what I want to do is show you where the uh, copy of the practice exam is. It's right here in the resource tab. Okay, so under the activities, when we look at the resource tab, we'll see practice exam. So, I mean, you can go and look at this practice exam yourself, along with all the PowerPoints, okay, for weeks 1, 2, 3, and 4. So, all that information is there for you, okay? So, that's where I'm pulling it from, okay, from your resource tab. And all you guys got access to this stuff too. Now, like for problem 1 here, I'm going to show you something else before we get started. We'll go way down to the back here, and there are the answers. Okay, so the answers are going to be right there for us. Okay, okay, so we got the answers there for us. Okay, so what I'm going to do for that problem, because I'm going to pull up uh, a sketch pad, and then I'm going to look at the points on it. Another thing I'm going to put on the graph itself is just those points that I need to, drive home my point, so to speak. Okay, so let's go back to it. Okay, so I've got 1 and 4 and -3 and 1. So I've got 1 and 4. Okay, great. Don't tell me I just got rid of the sketch pad. That sucks. Okay, so I got to do it again. Okay, no, there we go. Okay, so I said my order pairs were 1 and 4. I'm just going to put them down here. And I think it was -3 and 1. Okay, I'm going to go back and make sure that those were the order pairs that I seen on the graph. Okay, so yeah, I'm seeing them 1 and 4 and -3 and 1. Okay, so let's see, we've got 1 and 4. That's going to be about, we'll put 4 up here somewhere. 4. And then I'm going to put 1 out here somewhere. It doesn't have to be scaled to proportion right now because I'm not using all of the points. Okay, so that's that point right there, 1 and 4. Okay, let me put my x-axis here. Okay, and my y here. So you can see that y is 4 and x is 1 according to the labels on the graph itself. And then I'm going to have -3. And then I'm going to have 1. So that's my other order pair. So I got right here. So that's going to be that point right there. Okay. Now I've got the dubious task of trying to connect these. There we go. And I'll put arrows here. And then I'll just run straight through here. And put arrows here. Okay. Okay, so there's a lot of different ways I can find the slope. Okay, the slope is going to be the change between the x values and the change between the y values. Okay, let me change the colors here. Oh, okay, so what color is that there? Fill. Okay. One of the things I can do is I can use the formula. I can just say, okay, y2 minus y1 over x2 minus x1. Okay, this is going to be my second x value right here because it's the biggest. And then this is going to be my first x value because it's the smallest. When you say 1, 2, 3, 4, 5, you start with 1 because 1 is the smallest. And so if that's x1, then this is going to be y1 right here. And it's going to be y2 here. Okay, so I can just plug these into the formula and just go 4 minus 1. And then I can go 1 minus negative 3. Okay, and then that's going to give me 4 minus 1 will give me 3. And then, double negatives or subtract negative 3 will give you a positive 4. Okay, and we can just simply go plus, plus. If you're unsure of the rule with the negatives and you know you're not good with negatives, go ahead and just put it in the calculator, 1 minus negative 3. Get yourself a scientific calculator and just plug it in, 1 minus negative 3. And in that way, you're guaranteed not to mess this problem up. Because if you make that a negative, the answer is going to be wrong, even though you know what you're doing. Now, another way we can do this problem is I can just mark the change on the graph. So I can go here from here. And if I start at negative 3 and just count up to 1, that's going to be 4. Okay? And then if I start from 1 and count up to 4, that's going to be 3. Okay, and so I can see my slope there too, which becomes 3 over 4, like that. Okay, so that's our slope as well, 3 over 4. Okay, so the slope is going to be 3 over 4. Okay, so does anybody have any questions about this problem? Okay. Okay, if not, I'm going to give you guys one to do. Because you guys know me, I like to. Okay, so I'm going to give you guys one to do. And where's the eraser at? So I hope you guys are ready. Okay, so that's the slope problem. Okay, now you can solve it in a lot of different ways. So I'm going to give it to you and then I'm going to ask you to solve it. I'm going to change this back to black. Where's the pattern at? Right there. Okay, so here we go. Now, like before, I'm just going to give you the 2 points on the graph. So we're going to take negative 2. And we'll take 1. And then that'll be 1 point on the graph. And then we're going to take 3 over here. And we'll take negative 3 down here. And that'll be the other point on the graph. Okay, so you can see what your points are going to be because they're the only numbers on the graph. Straight through. And we'll go straight through here too. Okay, so I need you guys to give me the slope. Okay, so Peter and Stephen came up with the answers pretty quickly. Okay, Tanetta, how are you doing?
Can you hear me? Can you hear me?
Yes, I can hear you.
Okay, I'm getting it. Still coming up with the answer, and I'm actually driving, so it's not gonna be real easy.
Okay, so you can't. Well, okay, well, you can just, just follow along. Are you able to see what we're doing?
Yeah, absolutely. I'm looking at it now.
Okay, what are you seeing it on your phone or something?
Yes, I'm seeing it on my phone. So I would have to actually do the problem. I would have to pull over, but I am
Yeah,
seeing it on the
yeah.
phone, and I
Okay,
think
so yeah, we'll excuse you from doing the problems then. Okay, because I mean,
okay,
especially
I did, so I do have it.
you got to pull up. Yeah, it wouldn't be safe for you to be doing that. So yeah, I mean, you can just listen along, and then you can always download. Just go to the video in the archives and go back and see if you can answer the problems. Before just stop it and see if you can answer the problems on your own later.
I'll be at
Okay,
my
so there's
destination in
two ways we can
15
do
minutes.
this. One way we can do it is with the formula. And the other way we can do it is with the graph. Now these ways are interchangeable. So if somebody gives you an ordered pair, two ordered pairs, you don't have to just use the formula. You can think outside the box. You can graph those ordered pairs and then find the slope that way. A lot of times students think that you just gotta find the slope in the framework that the problem was given to us in. Okay, you don't have to do that. Okay, so here we're just gonna go down. Okay, and we can see we went down 4. Okay, because from 1 to 0 is down 1. So we can see we went down 4. And then from -2 to 0 is 2. That's 2 right there. And then from 0 to 3 is 3 more, so that makes 5. Okay, so we can see negative. Okay, right there. Okay. And anytime it's going down, your slope should be negative. Anytime the line is going down, you should have a negative slope. So in the end, our final answer is -4/5. Okay. Now, let's say, for instance, you're not good at that way. You can find the ordered pairs and use the formula on it. You can say, okay, well, one ordered pair is -2 and 1. And then another ordered pair is 3 and -3. Okay, so you could do that and then you could throw it in the formula. Just because we give you a graph and tell you to find the slope does not mean you have to use the graphing way. Okay, and just because we give you the order pairs does not mean you have to use the formula. You know, at the end of the day, as mathematicians, um, we become better mathematicians when we're able to, let's say, so we got -2 and then we got 3. So So we've got -3 minus 1, and then we've got 3 minus -2. Okay, and then we can see how that is. If we put it in the calculator, we can see that it's going to come out to be -4 over 5. Okay, so and I want to do one more thing with this just to prove a point, and then we'll look at some of the other problems, and the ones that you guys already know how to do. I'm not gonna belabor it and just go back through it and show you that problem again, because we only have a certain amount of time, and obviously if it takes you about an hour and a half to do the test, then to teach it, the whole thing would take more than that amount of time. Okay, so let's say they give me 2 and 0, and they give me 3, 2 like that. Okay, now they may ask me to find the slope with these two ordered pairs, and we may teach in the book that you can use the formula to find this, and it's correct. You can use the formula to find these, but you don't have to use the formula. Okay, what you can do is you can say, "What you know what? I'm not that good with the formula. The I get the numbers mixed up and stuff. So what I'm going to do is I'm just going to graph it. Okay, because remember what math is. Math is just a tool to, help us make better decisions. The math should not be driving our thought process. Our thought process should be driving the math. Okay, so we show you different methods, but you should be choosing methods that are most effective for you. Okay, so the first one's going to be 2, where x is going to be 2 and y is going to be 0. So I'm just going to put the 2 there and then drop a dot there for that point, just like that. Make that big dot. And then my next one's going to be 3 for x, and then y is going to be 2, and I'll put that right there. Then I'm going to put that right there. Okay, then I'm going to change it back to black, because I'm not even going to draw the lines. I'm just going to connect the dots. Okay, so from here to here, from 2 to 3, I went 1 space. I can see I went 1 there. And then from 0, because at this point right here is 0. That's 0 there. Okay, so that's actually a 0. It's 0 for x and 0 for y there. So from 0 to 2 like that, I went up 2. Okay, and so when I'm finished, I went up 2 and over 1. So my slope is 2. Okay, and so that's it. Okay, now that problem may also be written in a form like this right here. Maybe like, I'm gonna do the best I can with this. I'm gonna make up something. It may not hold for this equation, but I'm gonna make it up anyway. I say it'll probably, I'm saying if it crosses about right here somewhere. So I'm gonna say that's a -3. Okay, now this is not gonna hold for this equation. Let's see. Let me see if I can find one that'll work. Okay, so if I put a 2 in there for that won't work. Yeah, if I put a 2 there, then that would have to be 2, 0. Yeah, if I put a 3 here, 6, and that would have to be a 4. Okay, well, I would have to, it's probably going to be, it wouldn't be a whole number, so I'm not going to worry about that part of it. But the point is this right here. If it's written in this form, a different way of finding the slope is y equals mx plus b. Okay. Now, there's a formula I can use to find the equation for this, but I'm not going to go into that right now. There's your slope if that was the actual equation, okay, which is not the equation for this problem because it doesn't hold true for both ordered pairs. Okay, so that's the slope, okay, and the slope is simply the change in x and the change in y, okay. Where we at? Layers? Nope. History? Yeah, I think I learned something last time about erasing stuff. There we go. That's what I learned. Okay, so we're gonna go and we're gonna look at number two. Okay, number two is a perimeter problem. The perimeter of a rectangular painting is 360 centimeters. If the length of the painting is 96 centimeters, what is the width? Okay. Um, does anybody need to see this problem solved, this perimeter problem? Okay, neither one of you guys. What about you, Tanetta? Do you need to see this one solved?
I have a quick question.
Okay, fire.
Well, the formula for the slope was that y2 minus y1 over x2 minus x1?
Yes, that's correct. Yeah, that just
All right, I wasn't sure if you do if the x's over the y's or the y's over the x.
yeah, the Y's are up
All right,
top. It's always rise
all
over
right,
one. So it's just like this. Yeah, this is always the formula right here. And that means rise over run. And that's because the Y's are vertical on your axis and the X's are horizontal. Okay, so that's the
all right.
right there. Okay, thank you. Um, okay, Tynetta, do you need to see this the perimeter one? No, yes. Okay, so let's see. No perimeter. Okay, I'm assuming that most people know how to balance a checkbook, so we're gonna skip that one. Okay, what about number four? Does anybody need to see how number four is done? The yearbook club had 40 had the yearbook club had a meeting. The meeting had 30 people, which is which is 5/6 of the club. How many people are in the club? Does anybody need to see that one? Yes, no.
No,
Okay, welcome, Deanda. Do you need to see number four, the yearbook club meeting problem? Okay. All right. What about number five? Does anybody need to see number five? Uh, that's the mode. Okay. What about question number six? That's sort of like a DTR problem. Does anyone need to see that one? Okay. Number six. Okay. Now, number six, you got to find the rate first. Okay. What about number seven? Number seven is going to be a histogram. Does anyone need to see number seven, histogram? Okay. With number seven, uh, one of the things that we've got to do is we've got to categorize our data. Okay, so you know what I'm going to try to do? I'm going to try to pull up a new window so I can look at that new window. And then I'm going to put my sketch. I don't need that one, wrong one. Okay. Okay, so I got a sketch pad coming up. Okay, so it's got 21 employees. They're all listed. Want us to draw a histogram for these data using initial class boundary of 0.5 and an ending class boundary of 45.5 and 5 classes of equal width. Okay, so that's going to be, okay, so let's see if I can get this going up and running. Let's see. Okay, so here we go. And we can shut this one down so I'll have problems. Okay, so we're going to have classes. So I'm going to set up a frequency table first. So we're going to have classes. And then we're going to have tally marks. And then we're going to have frequencies. That's the first part. You got to organize your data. Okay, so that's our second part, frequency. All right, so this is what they're telling us. Okay, so each class is going to have 0.5. This one's kind of cut and dry too. And then that means I'm just going to start here and just add down 5.5. And all I'm going to do is just add 5 in each direction. Okay, because there should be 5 in the width, and then there should be 5, no matter what direction you go, whether you go horizontal or whether you go vertical, there should be 5, a difference of 5 between them. Okay, so it's going to be 10.5. Okay, and these are the boundaries. This is not the lower and upper limits. Okay, the lower and upper limits are probably going to be what we traditionally do is like take 5 from one and add 5 to the other one. So the lower limit for the first one is actually 1, and the upper limit for the first one is actually 5. I'll kind of show you guys that here in a second. Hmm, 15.
Is there only supposed to be 5 classes though?
What did they say? 5 classes? Oh, they said
Yeah, of
5
equal
classes.
width.
Oh, it said 5 classes of equal width. All right, so let's get rid of that part of it then. For some reason, I was thinking they were saying that the class width was 5. Yeah. So what you got to do
That'd be
now?
great.
You got to take you got to take these two numbers. That won't work, would it? Okay, so we got uh 0.5 like that, and then we got 45.5, and then we'll subtract these two things, and then that'll give us 45, and then we'll divide it by 5 because there are 5 classes. I don't know why I was thinking that I was going to say that the width was 5. Let's see, I'm trying to do it again. I just want it to be 5. And that's going to equal 9. Okay, so the class width is going to be 9. Okay, you got 5 classes, and each class has a width of 9. Let me go look at the verbiage again and see why I thought 5 was the class width. Oh, I see the word classes of equal width, and I just took out the of equal and just put class width. Okay, so that's where I came from. All right, so there we go. Okay, so we got 0.5 here. And then that's going to be 9.5, 18.5. And I'm just doing right now, I'm going to take the bottom part off. Right now, all I'm doing is just the lower boundaries. Now, the lower boundary is different than the lower limit. Okay, the boundary is what the limit falls into. 19, 27.5, 36.5. That's 1, 2, 3, 4, 5, 9.5, 18.5, 27.5. And there could be no gaps in these as well. Okay, that's why the math has to be really right there on it. 36.5. And then we're going to add 9 more, and that's going to make 45.5. Okay, and that's correct, because if we check out what they told us, okay, they said that we had to have 5 classes. Okay, so that's 1 class, that's 2 classes, that's 3 classes, that's 4 classes, and that's 5 classes. Okay, they said that the lower boundary had to be 0.5, and there we go. And the ending upper boundary had to be 45.5, and there we go there. And then they said they had to be a difference of 9, you know, well, they didn't tell us that. We figured that out on our own. Yeah, but that's all the information they gave us. Okay, now what we got to do is we got to start putting each one of these numbers into a class. Okay, so the number 7 is in between, I'm going to change it back to blank. It's in between 0.5 and 9.5, so it's going to go into first class. The number 2 is going to go into first class as well because it's in between 0.5 and 9.5. The number 16 will fall in the second class because it's right underneath 18. The number 11 will fall in the second class as well. The number 6 will fall in the first class. The number 1 will fall in the first class. The number 36 will fall in the fourth class. The number 31 will fall in the fourth class. The number 25 will fall in the third class. The number 20 will fall in the third class. The number 15 will fall in the second class. Okay, the number's 34 twice. So it's going to fall into the second class twice. I'm sorry, the fourth class twice. The numbers 29 and 29 are also going to fall into the second class twice. Well, I got 1, 2, 3, 4. I'm going to put that right there. That's so where we would mark these things. Okay, that's the numbers 29 twice. Then I got the numbers 24 twice. Let me see if I got anything else. I think that's it. Okay, so they said there's 21 of them. So I'm going to do some more math to verify that I didn't leave out anything. Okay, so I've got 5, 6, I've got 10, 13, 17. So obviously I've left some stuff out. Okay, so let me go back through this again. Okay, so I got the number 7 fell in the first class. The number 2 fell in the first class. The number 37. Let me remark them with a red this time. Okay, so I said 7 and 2 right here. Okay. I have to find a way to shrink this. Okay, let me do this right now. I got to find a way to get all this in here, push this down, so I don't have to keep moving backwards and forwards like that. Okay, and then this one right here, I need to move it over a little bit so I can look at everything at once. There we go. Okay, so I got 7 and 2. Then I got 37, which I totally missed out on. I'm just going to come down here. And then I've got 32, which is going to be right here. Then I got 27, which is this one. Then I got 22, which falls here. Then I got 16, which falls here. 11 falls here as well. Then I got 6 and 1, which I think I missed out on 6 and 1. 6 and 1. Then I got 36, which is going to fall here. Then I got 31, which is going to fall here. Then I got 25 and 20. So there's 25 and 20. Then I got 15. 15, 15. 15 is going to fall under 18.5. Then I got two 34s. Okay, there's one 34. There's the other 34. And then I got two 29s. Okay, so there's one 29. And then there's another 29. Okay, and then I got two 24s. One 24, another 24. Okay, so I'm going to add them up again, and just to make sure that I got 21. Okay, so I got 5, I got 7. I'm going to add the 3 to it to make it 10. Then I'm going to add the 6 to it to make it 16, 17, 18, 19, 20. Oh, great, I missed. Oh, and then the bottom one makes 21. Okay, so there's 21. Okay, so I'm going to add them again just to make sure. I've got 7 plus 3 makes 20. Okay, then I've got 6 that makes 20. I've got, let me do it again, 7 and 3 makes 10. 10 plus 6 makes 16. The 1 makes 17. The 4 makes 21. Okay, so there's 21 of them. Okay, so I'm going to put the frequency here. 4, 3, 6, 7, and 1. Okay, and we can say 13 plus 7 is 20, and then 20 plus 1 is 21. Okay, so we verified it. Okay, now I've got everything I need to create my histogram. Okay, the histogram is going to come straight from this frequency table. Okay, so that's where the histogram is going to come from. So what I'm going to do is go right back here and get another sketch pad. Hopefully it gives me a different one. I don't know if I'll be able to do that or not. We'll see. Okay, give me another sketch pad. Oh, great, it doesn't. It gives me the same one. Okay, well, what I'll have to do is go down here and look at the bottom part. the actual answer. Okay, so here's the actual answer here. Okay, and then if we look at the labels above the 43671, we can see in our frequency the 43671 and 1. So that's going to be our vertical axis. Okay, and then the horizontal, we can see that we have our class widths. See the 0.5 to the 9.5. Okay, let me see if I can actually. Okay, if we were actually creating a table for it, it's challenging when I can't see my own stuff. We would actually do something like this. And then all of this information here, that let me put it in purple. All of this information right here is going to be on your horizontal axis. Okay, so you're going to have like 0.5, you got like 0.5, and then 9.5, like that. You don't have to put the 9.5 twice, you just have to put it once. And the 18.5, like that. I can't put them all down here, so I'm not going to try to. I'm about to do this one kind of in the background. There we go. Okay, and then the same way with the tallies. So for here, let me use a different color, green maybe. We're going to take these right here. Okay, and so they'll be along the sides here. 1, 3, 4, like that, 6, 7, and so on. So if we wanted to do, let's see, number 3. Well, we can do the first one actually. The first one will probably be the best one to do. It's going to go all the way up to 4. So we're just going to go right here from 0.5 to 9.5. And then we'll just shade this in. Okay. And then if we wanted to do the second one, which is from 9.5 to 18, that's going to be 3. We'll just connect and go right here to 18.5 like that and just shade it in. Okay, now remember, histograms work off of intervals or continuous data. So you shouldn't have like one number there. So that's really, that first one is from 0.5 to 9.5, and then the second one is from 9.5 to 18.5. And there should not be any spaces between them. They should always connect unless the frequency is 0. Okay, so that's it with the histogram. Needless to say, with the histogram, it's best to use a table. And then you notice that I use a lot of different math just to verify that I added up everything correctly. Okay, because it doesn't take that much to mess it up. If you miss out on one number, then the whole thing's going to be off. Okay, and so that's why, I went back and I counted them up and said, okay, they said there's 21. Let me make sure I got 21. And sure enough, I didn't have 21. Unfortunately, the fact that we're human means that we may miss out on something or skip over something or not see something. And then that's going to create a challenge for us when the answer is wrong. But, um, there are checks and balances in place. Like if there's supposed to be 21 numbers, when you count them up, there'll be 21. If there's not 21, you missed out on one. Or if there's more than 21, you duplicated or added something you weren't supposed to duplicate or add. But what you see on your frequency distribution table, which is what this is called, you can call it frequency table, frequency distribution table. What you see on your frequency distribution table is exactly what's going to be dropped down on your histogram. Okay, the bars are going to represent the frequencies, and the classes will represent your horizontal axis. Okay, does anybody have any questions about this one? Okay, hold on, I just muted myself. Okay, any questions? Any questions? Oh, not a problem, Claude. Um, yeah, with this one, just make sure you're careful. One of the mistakes that I made is I didn't read correctly, whether it was talking about class width versus the amount of classes. Okay, that can mess you up if you're not that good at reading, or you read it too fast, or you don't read it carefully. That's one of the things about word problems. You have to do a lot of reading. Okay, so that's 7. What about 8? Does anybody need to see 8? This is an odds problem. Okay, Clark. Okay, so we'll pull back up our table. We're gonna clean up all this. Well, you know what? I'm gonna go back to the way I learned how to do it. Quickest way to do it. That's not working. Gotta go all the way down to where we erased that. Okay, there we go. Well, you know what? I found out. I think if you go all the way to the bottom, you can just hit New Document. Let's stop that. Okay, so here we go. Okay, now this is an odds problem. So the odds look at uh, favorable over unfavorable, or we can just say favorable like that to unfavorable. Okay, so what are the odds in favor of choosing a white marble? Okay, so there are 4 white marbles. Okay, and there are 5 other marbles. Okay, so the odds of choosing is 4 to 5. You got 4 favorable and you got 5 unfavorable. And so that equals 9. And the two together should equal 9. Now, what we say, this should be really what this is the probability. There's a lot more math behind this, but you don't have to worry about the math because the math is going to take you off into, dividing fractions. Okay, if you just look at it this way, it'll be a whole lot easier. A lot of times we're tempted to show you all the math, but the rest of the math on this is just going to make it complicated for you. Okay. Um, yeah, I'm not going to do the math to it, but I'll put it over here. The probability of choosing a white marble is 4 to 9. A probability of not choosing a white marble is 5 to 9. Okay. And that's really, 4 over 9 divided by 5 over 9. Because that's what that fraction bar means right there. That's what we call a complex fraction, like that. Okay. So I'm making that fraction bar longer. So that's the math behind it. Okay, but you don't have to know all that. Like, you don't even have to know the probability of favorable. All you have to do is just know that there are 4 favorable and that there are 5 unfavorable. So therefore, the odds are 4 to 5. Even though odds are based upon the probability of favorable over the probability of unfavorable. Sort of like a shortcut that you can take without having to do that. Because if you do the long way and you do all the math out, it's still going to end up with the same answer when you keep it, change it, flip it, change that to multiplication, and do that. The cross canceling here and here still takes you to 4/5. Okay, so you still end up with the same answer. Okay, but instead of doing that, we just say, okay, it's favorable 4, unfavorable 5, and that's our odds, 4 to 5. You just don't want to get bogged down into that, having to do all that math. Okay. Does anyone have any questions about that odds one, or are we're feeling better with it now? Okay, yeah. It's kind of cut and dry on it. There we go. Okay, what about number 9? Anybody need to see number 9? 9. Okay, number 9. Number 9, an ordinary fair die is a cube with numbers 1 through 6 on the sides, represented by, what is it saying? Painted spots. Imagine that such a die is rolled twice in succession and that the face value of the two rolls are added together. The sum is recorded as the outcome of a single trial of random experiments. Okay, so they want to know, what is the probability of getting a sum that's greater than 5, and then what is the probability of getting a sum that is divisible by 6. Okay, so that's the problem. Okay, well, first thing I'm going to do is I'm going to identify all the possible outcomes. Okay, so I'm going to go like this right here. 1 and 1, 1 and 2, just like that. 1 and 3, 1 and 4, 1 and 5, and 1 and 6. And all I'm saying is that I could roll a 1 on the first die, and then I could roll a 1, 2, 3, 4, 5, or 6 on the second die. Because the first die, is what it is, but then the next die could be any of the 6. And then I'm gonna, if that didn't happen, then I could roll a 2 on the first die, and then I could roll a 1, 2, a 3, a 4, a 5, or a 6 on the second die. Okay, there are going to be 36 of these outcomes. Okay, and that's based upon a rule called the multiplication rule. Okay, the multiplication, I'm going to put this in the chat. Multiplication rule states that if an event can occur X amount of ways and another event can occur X amount of ways, when they occur, how do you say it? In succession and are independent of each other, you simply multiply the amount of ways the first event can occur by the ways the second event can occur to come up with the possible outcomes. Okay, so that's the rule. Okay, so let's say you got four shirts and 7 pants, and you want to know how many outfits can you put together with these 4 shirts and 7 pants. Well, the first event can occur 4 ways. That's 4 shirts. The second event can occur 7 ways. So what are the total possible outcomes? It's going to be 4 times 7, which would be 28 outfits. 28 ways. Okay, so that's what that rule means. So if the first die has 6 numbers, has 6 ways it can occur, And the second die has 6 ways it can happen, because occur and happen mean the same thing. Okay, first die has 6 ways it can happen, and the second die has 6 ways it can happen. We simply go, the multiplication rule say, we just simply say multiplication rule says 6 times 6 equals 36. So that means that there's going to be 36 ways or outcomes for this event. Okay, so far we got 12 of them. Okay, so now we're going to go 3. The first one can occur 3. The next one we can say, well, the first one could be a 3. We could roll a 3. Then the next one could be 1, 2, 3, 4, 5, 6 for that one as well. And then we got 4 and 1, 4 and 2, 4 and 3, 4 and 4, 4 and 5, and then 4 and 6. Then we got 5 and 1, 5 and 2, 5 and 3, 5 and 4, 5 and 5, and 5 and 6. And then finally we've got 6 and 1, 6 and 2, 6 and 3, 6 and 4, 6 and 5, and 6 and 6. And so if we count all these up, it's going to be 36. You know, it's going to be 6 across the top, and it's going to be 6 rows. So it's going to be 6 rows and 6 columns. So that's going to give us 36. Now we need to find a sum that's greater than 5. Okay, a pattern is going to emerge here. Okay, we're going to see the ones that are greater than, that's going to be greater than 5 are going to start at a certain place. Okay, because we can see, let me change the colors here. Okay, so I'm going to change the colors to red. Okay, everything that's 5, we can see it forming right here. There's 5 and less, and then I'm just going to triangle them in. Everything that's 5 and less is going to be right here. Okay, and these patterns are going to always hold because these things are counting, you know, up as you go. So we're saying that it's going to be greater than 5. Now we can do this 2 ways. We can sit here and count all the ones at the bottom, or we can count all the ones at the top. We can say, okay, the ones at the top are going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 that are not greater than 5. Okay, the probability of something, of everything is 1. Okay, and so we're going to subtract out the 10 that are not 5. And then if you wanted to go the other way, you could just simply go in and just say, well, okay, I'm going to add up the other ones. Of course, at this point, we now know it's 26 of them that are greater than 5. Which, I mean, you could count all 26 up. But here we're just going to say 36 over 36. Minus 10 over 36. And then that's going to give us 26 over 36. And then we're going to divide both of these by 2. And then that's going to give us 13 over 18. Okay, so there we go. So that's going to be our answer. It's going to be 18 over, it's going to be 13 over 18. So it's going to be 13 over 18. So that's going to be our probability. Now, you could count up the other way as well. You can go, like you say, 1, 2, 3, 4, 5, 6, and then it's going to keep counting down. 6 and 5 will give you 11. Okay, we got 6 and 6, that's going to be 12. And then we've got 5, which is going to be 17. And then we've got 21. And then we've got 26. So you can count them up as well. You don't have to do the 1 minus to figure out, what it is. The next one says the sum is divisible by 6. Okay, that means that it's got to either be divisible by 6, going to be 6 or 12. So we're going to look for numbers that are 6 or 12. Okay, so those are the only ones that
It
are going
says
to...
not.
Hello?
It said not divisible by 6.
Okay, so if it's not divisible by 6, then we're still going to look for the ones that are 6 and 12. And then we're going to subtract those out. Okay, so thank you for correcting me. So it's not divisible by 6. So we're going to find the ones that are divisible by 6, which are going to be 6 divided by 6 and 12 divided by 6. So, and let me pick a different color here. So I'm going to pick blue. And I'm going to take, okay, so that's 6. That's 6. That's 6. That's 6. And that's 6. Okay, and then I only got one that's 12, which is right there. Okay, so I've got 1, 2, 3, 4, 5, 6. So I got 6 of them that are divisible by 6. Okay, which that actually equals 1/6. Okay, so in the end, I can say I've got 1 minus 1/6, which equals 5/6. Okay, so the ones that are divisible by 6 is 1/6, and the ones that are not divisible by 6 is 5 out of 6. Okay, so that's the way we do it. But in order to do this problem, you have to have the possible outcomes. Okay, and then you look at your possible outcomes, and then out of your possible outcomes, you find your favorable outcome. Okay, let's do this. Let's take a 5-minute break or a 6-minute break, and then that's going to put us at 11:10, and then we'll come back and finish up. Okay, so we're going to take a 6-minute break. Then that's going to give us a chance to finish up. Give me a chance to take a break and get something to drink. Give everybody a chance to do a restroom stop, and then we'll finish up. So I'm going to put on some music for about 6 minutes. We'll get started back at 11:10. Well, the answer was 5, 6. For not divisible by 6 was 5, 6. Hello, everyone. This is Professor Clark. Welcome back. Okay, so we just got finished looking at number 9. Okay, we're going to scroll through these, and you guys let me know the ones that you want to look at or do. Okay. Um, Now, if you're looking at it, okay, and you need more time on it, I always send out an archive on these things as well. So there you can go back and play it 15 to 20 times and get a better understanding of exactly what we did. I mean, you could slow it down and see if you can answer the problems, and then pause it and hit play again. That's the beauty of having recorded. Okay, now Claude, you had a question. What was your question? Oh, you're muted. Okay, hold on for a second. Okay, you should be unmuted now.
There you go. Sorry, sir. I missed your instructions at the beginning, so I didn't know if we could speak or not. Um, I guess you already answered it by saying that you're going to release an archive of this, so I can go over that question a couple times. I got lost a little bit at the end when writing the answer as a fraction. It said P equal P parentheses A equals, and then P parentheses B equals. Are those two portions part of the same fraction, or are those two separate answers to one equation?
Which one you're talking? Oh, you're talking about the last step
Yep.
down here at the
Question
bottom.
9.
Yeah, let me
Yes, sir.
let me box these up. Okay, this one right here is the ones that are not divisible by. Okay, so this was our answer right here, 5, 6. Okay, but in order to
Okay.
come up with that 5, 6, instead of figuring out all the ones that were not divisible by, we figured out the ones that were divisible by.
Word.
Okay.
Right.
Right. So the way probability works is probability lies between 0 and 100%, between 0 and 1.
Right.
Okay. So if you figure out the probability of everything that can happen, it's going to be 1. So the probability of something happening plus the probability of it not happening equals 1. So what is the probability that it will rain today? 75%. What is the probability that it won't rain? Will be 25%, because 75% plus 25% equals 1.
Equals 100%.
So that's why we figured out the 1/6, because that was the probability that it was divisible by 6. Now the probability
Okay.
that it's not divisible by 6 is going to be 1 minus the probability that it is divisible by 6. So that 1/6 is divisible by 6, and then we take that 1/6, subtract it from 1, and then that gives us the probability that it's not divisible. And,
And to subtract 1/6 from 6, you have to make it 1 over 1 to have a whole number to work with as a
right, so
fraction.
that 1/6, then you take that 1 and make it 6 over 6. And then 6 over 6
Correct. Okay.
minus 1 over 6 gives us 5 over 6.
I think I got you. Some of memorizing all these rules or even writing them down just to refer back to them, they get jumbled up in my head sometimes.
Yeah, one of the things that you have to do when you're looking at that part of it is with probability. Okay, you just have to remember that the probability of any event, or this is what you'll see this right here, has to be um, greater than or equal to 0,
Yeah.
and it has to be less than or equal to 1. Okay, so that's the probability of any event, and then the sum of all probabilities, and I'm going to use the summation. You guys have seen this with the standard deviation. The summation of all probabilities is equal to 1. Okay, so if there's uh, a a 75% chance, you'll make an A on the test. Okay, and then there's so that's the probability of an A. Now, if we wanted to find the probability that you will not make an A, so the probability of not an A, and then we kind of notate that like this: the probability of not an A. So we say
which I guess could be the probability of B.
yeah, we could call it the probability of B, but in order for us,
Just looking at the way
yeah,
this problem is laid
that
out.
prime, that prime, that mark, that exclamation, that accent mark above the A says not A.
Yes.
So we want to say the probability
Okay. Got
of not A. Okay, so then we got, because you got two probabilities. The probability of A or not A is everything, because either it's A or it's something else. Because even if you said it was a probability of B, and this is how anal math can get, there could be a probability of C, D, and E as well.
it. Right.
So that's why we use A or not A. Like we say, well, what is the probability? I'm talking to you. What's the probability that that you're Hispanic? Okay. Well, just
Right.
because you're
Why not?
Hispanic does
One.
not, or not Hispanic does not mean that you're automatically Hispanic white, or Hispanic black, or you could even be Asian. So
Right.
so when we say, like, for instance, for me, I'm black, and you say, well, what's the probability of you being black? Well, if I'm not black, it doesn't mean that I'm automatically white. I could be Asian.
Right.
Okay, and so that's why we say black or not black, because either I'm black or I'm not black. Even if I was Asian, I'm still not black. If I'm white, I'm still not black. If I'm Latino, I'm still, you know, depends on what race you come from, whether you will be black or white.
It closes one door but opens up a whole nother group of probabilities.
Yeah, yeah, and so that's why we have to do not versus is. So when
I
we say
got
the
it.
probability that it's not A, that's going to be 1 minus the probability of A. Let me put that
Okay.
not there. Okay, so that's the way it works. Okay, sometimes it's easier to prove what something is not than to prove what it is.
This is true.
Yeah, and so that's and that's logic and reasoning that we use to determine whether you want to count up everything that it is versus everything that it's not. So you just look and say, well, it's easy to count up what it's not and then subtract that from 1 to find out what it is. So that's the premise or basis we use as we start through this process. Now, you could count them all up, instead
No
of,
thanks.
yeah, you could count
I
them
got
all up. In this case, you could, because there's only 36 of them.
right.
Yeah, so it might take you 5 or 10 minutes to count up the ones that are not divisible by 6.
Sick. Yeah.
Yeah. Okay, and then you would have to make sure you simplify the fraction to its lowest term, because like, say for instance, I mean, you're going to come up with 30 over 36, but then both of those numbers can be divided by 6, and then 30 can be divided by 6 to come up with 5, and 36 can be divided by 6 to come up with 6, and so then that would give you 5 over 6 as your final answer. So that's the part
Okay.
you have to
So
make sure you watch out for too, because sometimes people come up with the right answer, but because they don't simplify the fraction, which we learned way back in arithmetic, all fractions always have to be simplified to the lowest terms. That's a law. Like, humans, need oxygen. That's not something you have to tell us. We automatically know we need oxygen to live. Well, in math, you automatically have to simplify, fractions to the lowest term. That's not something
Alex has
that
reminded
we
me
ever
that
have to
many
tell.
times.
Yeah. So just watch out for that one. Okay, so
Okay. Thank you.
you're welcome. So that's 9. Does anybody need to see 10?
Evaluate the expression.
Okay. On number 10, watch out for that last one. The last one, -6 squared. I'm going to put it in here, -6 squared like that. That equals -36. That's not a positive 36. Okay, so watch that. Okay, and I'm going to show you the difference between the two, because a lot of times people get these two mixed up, and this will get you. Okay, and you're going to see it here. One of these will give you a positive 36, and then the other one will give you a -36. So that second one's not inside parentheses, so watch it. Now, the one in the middle, negative 1/4 raised to the power of 2. Okay, you're simply you can just say negative 1/4 times negative 1/4, and that'll be 1 times 1 will be 1, and then 4 times 4 will be 16. Okay, so that one will, yeah, and then the double negatives make a positive there. Okay, and then the first one, of course, will be, um, 4 times 4 on that one will be 16/5. So just watch out for that one. All right. What about number 11?
I'd like to talk about number 11,
Okay.
classifying it. Angles as a,
Okay. All the ones that are right angles will be 90 degrees exactly. And anything that's acute will be less than 90. So that'll only be B. And anything that is obtuse will be more than 90. So that'll be C.
got it.
Okay. What about 12? That's an equation. Anyone needs to see 12?
Is order of operations and distributive property?
No distributed property here because the left side is already a simplified expression. The only thing you're going to have to do on this problem is the addition property for solving equations and the multiplication property. Okay, you're simply going to isolate the W, like you'll add 6 to both sides, and then that'll give you 3W equals negative 18, and then you'll divide 3 from both sides, and then that'll give you W equals negative 6. And that's what we call the multiplication property. The multiplication and the addition property, like if there's addition and subtraction in the expression, once it's been simplified, then you have to do the inverse of addition or subtraction to eliminate that number in operation. Like, let me get out of this. I'll show you what I'm talking about. Now, with some of these problems, if the expression has already been simplified, you don't have to simplify it. Like, I'll show you what I'm talking about. Okay, this one right here that I'm going to put up here, this one has not been simplified, so it'll need to be simplified. Simplified means that you can combine things. And let's see, 3x here equals. Now, on the right side here, nothing's going to need to be simplified because it's already just a constant term. Now, here's another one right here, 2x plus 4 equals 10. Okay, the bottom one doesn't need to be simplified because there's nothing you can combine. The top one does. Okay, so when we look at the when we look at the let me change out the color in it. When we look at the bottom one here, we've got the addition of 4 and the multiplication of 2. Okay, so we've got two things, the addition of 4 and the multiplication of 2. So that brings us into the addition property for equations and the multiplication property for equations. So with the addition property, we just subtract 4 from both sides. And that gives us 2x. And then that equals 6. And then we divide 2 from both sides. And x equals 3. Okay. And because we're multiplying by 2, so that is the multiplication property. If we were dividing by 2, that would still be the multiplication property. Okay. Now the first one is a lot different because you can combine things. You can use the distributive property right here to combine and release the parentheses. And that's going to give you 3x plus 6 plus 3x here plus 20. And then you can combine some more. You can take 3x, and 3x will give you 6x plus 6. Now you can't combine anything else because you can't add the 6x and the 6. So at this point, you turn to the addition property of solving equations and the multiplication property of solving equations. So now you're right back to where you were in the first step of the last problem. Okay, so that's what it's all based upon. You got to see if you can simplify the expression first. That's why, like when you're working with the Alex Pi, the first thing that we teach and show you is to simplify expressions. Then once we finish simplifying expressions, then we move into the equations. Because sometimes when you're solving equations, you may have to simplify expressions before you can solve the equation. Like we did with this problem, right? I'm going to call this problem number 1. Like we did with problem number 1. Versus problem number 2, we didn't have to simplify anything. It was already simplified. Okay. What about number 13? Does anybody need to see number 13? Does anybody need to see number 13? We're good with 13. Okay, yeah, 13 is, okay, Tanetta, 13 is going to be combining two shapes. Okay, so we're going to be adding two shapes together on 13. Okay, so what I'm going to do is I'm going to put it right here. One shape is going to be, then I'm going to change the color of it so you can see what I'm talking about. Okay, so we got two shapes involved here. We've got a rectangle and we've got a semicircle. Okay, and then let's see what they're asking us for. They're asking us to find the area of the garden. So we got to find the area. So we got to know two formulas. We got to know the formula for the rectangle, which is going to be 22. I think that's 22. Let me make sure that's right. 22 by 33. Okay, and so the rectangle formula is going to be area equals length times width. And then we got to find the semicircle. Okay, so we've got to find the area of the semicircle. A semicircle is a half of a circle. So whatever we do, we got to either divide it by 2 or multiply it by 1/2. So we're going to have, the formula for a circle is pi r squared. Okay, pi r squared. And then we're going to divide that by 2 because it's half of a circle. Okay, and so those two together are going to form the area of this garden. I'll make sure that's what they called it. Yeah, area of a garden. Okay, so what we'll do is we'll take the information we got. The length and the width are 22 times 33. And that's going to be 22 times 33. 726. So that's going to be 726. Now, right now, I'm not going to put the unit of measurement, but I know if I don't put the unit of measurement in the end, it's going to get marked wrong. So that's going to be 726 square feet, but I'm just going to leave it like that for now. Then I'm going to go and figure out what the area of the semicircle is. Okay, so here we go. I'm going to put 3.14 because that's what pi is approximated at. Now, once I put that 3.14 there, this line is going to become wavy because I'm saying it's an approximate. And then r in this case is going to be the radius, which is going to be half of that 22. If we look here, the diameter is 22. Okay, the diameter of the semicircle is the same as the length of the rectangle. Okay, so that's going to be 11. And that's going to be 11 squared. All that's going to be divided by 2. So when I'm doing that, I'm going to end up with, okay, 3.14. 11 squared is going to be 121. Divided by 2. Okay, so I'm going to take 3.14 multiplied by 121, which is going to be 379. 379.94. I'm going to divide that by 2. Then that's going to give me 189.97. Then I'm going to add that to the 726. And then that's going to give me 915.97 square feet. Okay, so let me look and make sure I got it all. Okay, it says be sure to include the correct unit in your answer. Okay, so we took the area of the rectangle, which was the length times the width, 22 times 33, came up with 726. We took the semicircle, which is the area of a circle is pi r squared. And then the semi means half, so we divided that by 2. Okay, and so when we divided that by 2, that gave us 189.97 square feet. And so we took the 189.97 square feet, the 726 square feet, we added it together, and that gave us 915 and 9,700 square feet. Okay, but once again, what we had to do is we had to take those two shapes and combine them together. Okay, we had to figure out the area of one and then the area of the other one. And sometimes you get to add the areas together, and then sometimes you have to subtract them. Okay, what about number 14? Anyone need to see 14? Okay, and what about 15? What about 16? Okay, so Claude, you wanted to see 15? Hello, Claude? Okay,
Yes, sir.
okay. Okay, so 15 is a median and mean problem. So those are two different measurements of central tendencies. Okay, so what we need to do is we need to take those numbers, and then we're going to say we got two threes. Okay, sorry about that, guys. I was saying goodbye to my wife. That's why I muted you guys. Muted myself for a second. Okay, so we got two threes, a seven. We got 12. Let's see, we got 15 and a 16. Okay, and just like the histogram problem, I'm going to count them up, make sure I put them all in. 1, 2, 3, 4, 5, 6. And it says I got 6 students, so I got them all in. Okay, checks and balances are always good, especially when you get my age. You know, I'm pushing 50, so it's just always good. And even if you're young, you still need to check and balance in case you missed a number, because if you miss something, something's not gonna go right. All right, so in this problem, to find the mode is going to be easy. Let's see, did they ask for the mode? No, they asked for the mean and the median. Okay, so let's go for the median first. Okay, the median is going to be easy. It's going to be the number that's right in the middle. But in this case, you got two numbers in the middle, right there. You got 7 and 12 in the middle. Okay, you got two numbers on the outside to the left, two numbers to the outside on the right. So the two on the right and the two on the left. So you got two in the middle. Now if there's one in the middle, you don't have to do any math. You're done. But in this case, you do have to do math. So what we got to do is we got to add the two together, 7 plus 12, and then we got to divide it. We got to find the average. So that's going to give us 19 divided by 2 will equal 9.9. Okay, so that's the median. That is the median. And the median is just like what it says, the median of a street is right in the middle. Okay, so that's the median. All right, now the mean is going to be what we use to find grade sometimes. It's an average. Okay, so that means that we got to add all these numbers up. So the mean is found by the sum of the numbers divided by the amount of numbers. And that's our formula, the sum of the numbers divided by the amount of the numbers. So we're going to take all those numbers and we're going to add them up. Okay, and that's the way it's going to go. So if we took 7 and 12, we already know that's 19. And then we're going to take the 19 and add it to the 16. And then that's going to give us 35. And then we'll take the 35 and add it to the 15, and that will give us 50. And then we'll take the 50 and add it to the 3 plus 3 is 56. So that's going to give us 56 divided by 6. Okay. And I'm not going to do the what's column on that part of it. I'm just going to turn it to the calculator. Okay, so that's going to be 9.333. So the mean is going to be 9.333. And we can write the mean like this. Okay, if it is a sample mean, or if it is a population mean, we can use mu. But in any event, whether you use a population mean or a sample mean, The answer is going to be the same here. Okay. Okay, once again, we add them up. And I choose the 19 and the 16 together because I knew that if I took the one from the 16 and gave it to the 19, that would give me 20. And then I was just looking at 20, plus 15, which would give me 35. Now I could have went, the 19, took the one from the 16, gave me 20, and then took the two 15s, added them together, came up with 30, and then take the 30 and the 20 and brought them together and come up with 50, and then added the 6 to it to come up with 56 that way. Okay, that's called, compatible numbers. Anytime you want to add and multiply numbers quickly and fast, some numbers are more compatible for adding than others. So rather than just go 3 plus 3 plus 7 plus 12 like that, I look for compatible numbers. Numbers that can be put together easy. Okay, so here we go. 9.33 is our mean, and 9.5 is our median. Okay, so that was number 15. Okay, feel free when I give you the archive, you go back and just look at it on multiple occasions, and that should help you out. I got to find my battery now, my charger, because I'm starting to run out of juice on my battery. What about number, how am I twisted up here? What about number 16?
Yes.
Okay, so you guys want to see 16? Okay. Uh, give me 1 second. I need to put a battery charge to.
So are you going to be wrapping up at 12, or are we going to have a little bit more time?
I got to run at 12 because I got to be in the office. Actually, I live in a koi, and the office is in Winter Park. And so what happens is, they set me up for tutoring, and because I'm the only one that's doing the tutoring, it's in building, I guess 3F 112. I have to be there at 1. So, I I I don't have really no time at all to leave my house. I got to basically pack up and run straight out the door. And normally what I do is I get up at 8 in the morning and take my shower and stuff. Like right now, I'm dressed for work because I don't even have time to like dress or anything. So, unfortunately, when I got tutoring, you know, which happens to be these last few days, I've got to pack up and run right at 12.
Okay. Will it be possible to get some of your time at any time before this is done? I know you have another go-to training sometime this week. I don't know if it's tomorrow or later today.
Actually, I want to say it's Thursday. What's the day's Tuesday, right? Yeah, it's
Yes,
Thursday.
sir.
It's Thursday 3 to 5, and the Thursday one will be a whole lot better because I'm actually coming from tutoring, and then I'll stay. After the set, I can stay as long as need be on that day.
Okay.
Okay.
Because I definitely know I'm going to have more questions, but I see that we're running short on time.
Okay. Okay. Not a problem. Okay. Well, 16 is going to be a humdinger because it's a DTR problem. Okay. Number 16 and I'm going back up. Number 16 and number 6 are similar, because they're both, you got to find rates, and, one of them is a DTR problem, and then another one is like a VTR, which is the volume, okay, times the time times the rate. So one of them you're moving distance, and the other one you're moving volume. But the concept is still the same. The volume equals the time times the rate, and in this one, the distance equals the time times the rate. Okay, so what I'm going to do is let me clean this up. Okay, and then I'm going to start with a premise. A premise is basically, a well thought out, conclusion or basis to, to build a foundation from. Okay, and so the premise is this right here: D equals TR. Now that means that, and I can put a center dot right here. Okay, so that's my premise. Now on that water pump problem, you were going to have V equals TR. Okay, so they're basically the same thing. Okay, in order to pump the volume of water, you got to multiply the times the rate, how many gallons it can pump an hour. Okay, here is how much distance you can travel an hour. So this is my premise right here. That's gonna always hold. Okay, so the problem says a motorboat takes 5 hours to travel 150 miles upstream. The return trip takes 3 hours going downstream. Okay, what is the rate of the boat in still water, and what is the rate of the current? All right, so what I'm going to do is I'm going to take what I know. The distance is going to be 150 miles. Okay, okay, because that's what it's saying. And whether you're going upstream or downstream, it doesn't matter. It's 150 miles because you're going the same distance. You're just going it in different directions. Now, for the first one upstream, it says it's going to be 5 hours. So that's your time. Now, the thing that I don't know is I don't know the rate. But in this problem, I've got two rates. I've got the speed of the boat and I got the speed of the current. And if you look at the problem right underneath there, it's telling you that the rate of the boat and the rate of the current. Okay, so the rate of the boat, I'm going to call that X. And the rate of the current, I'm going to call that Y. Now, this is going to be X minus Y. Okay. Two things tell me it's going to be X minus Y. Because if you're trying to go upstream and you just like if you take a piece of paper and you drop it in the water and it's supposed to be going upstream, okay, the current is going to push it backwards, so it's not going to go forward. Okay, so if it does nothing, it's going to fall back. Okay, so that's one thing that's going to tell me that that the speed of the boat is being slowed down by the current, the subtraction. So it's being subtracted. That's what slowed down means. Okay. Another thing it's going to tell me is the time. It's taking 5 hours for this boat to do the same thing that it's able to do in 3 hours. Okay. When it goes downstream. Okay. Now, so I'm going to look at now. That's one equation. This is the upstream equation. Okay. This is how I'm defining upstream. Okay. Well, you can't define upstream and downstream the same. Okay, you can't. Okay, because the hours are different. The only thing that's going to be the same about them is going to be the distance. Okay, the problem says that the return trip takes 3 hours downstream. So I've got 3 hours for my time. And once again, this is the time. Put a T right above that. And this whole thing right here is the rate. Okay, and then of course this is the distance here. Okay. Obviously, downstream, I'm getting there faster. Even though the boat's going the same speed, I'm getting there faster because the current is adding to the speed of the boat. So if the boat is going like 20 miles per hour and the current is going 5, then you can take the 20 for the boat, and add the 5 for the current, and now that boat's going 25 miles per hour. So the current is making it go faster, so I'm going to add. Okay. When you're going downstream, the current is going to make it go faster. Like say for instance, if you get in a river and it's going downstream, if you set still, you're still going to move. Okay, and if you get in a boat and you're paddling, that boat's still going to go, and that boat's going to go a whole lot faster downstream. It'll probably go faster than you can paddle downstream than it will upstream. You really got to fight against the current. Okay, so the current is against you upstream, so that's why you subtract. It's for you downstream. Okay, so this is the problem right here. Now, I can do some things before I start this problem to make it simple. I can distribute if I want to. Okay, and I'm going to say this is downstream. Okay. But instead of distributing, what I'm going to do is I'm going to try to shrink the problem. I'm going to start off with the multiplication rule. Okay, and what that means is I'm just going to divide all this by 5. Okay, and I'm going to divide all this by 5. Okay, these 5s are going to cancel out. And then I'm going to divide all this by 3. And I'm going to divide all this by 3. And these 3's are going to cancel out. Now, can I distribute and come up with 5x minus 5y and do it that way? Yeah, I can. Okay, either way will work, but I'm just doing it in a way where I got less work to do. All right, so now I'm going to go back to the black, and I'm saying 150 divided by 5 will give me 30. And that's going to give me x minus y. Because remember, the 5's cancel out. And then the bottom here, I'm going to have 50. And remember, the 3's cancel out, so now I got x plus y. Okay? Okay, so that's all I did. Okay? Now, I could have distributed, but then if I distribute it, now, I got 150 equals 5x minus 5y. And then I got 150 equals 3x plus 3y. Now, anybody knows anything about, when you have two or more equations, that's called a system of linear equations. Okay, and so when you got a system of linear equations, I'm going to type that in there, system of linear equations. Okay, when you got a system of linear equations like that, you can use two methods. You can use the elimination method or substitution method. Now, the elimination method is really elimination by addition versus elimination by substitution. But either one of these methods will eliminate one of the variables for you, whether you're adding or substituting. The problem with the distributing is you'll run into trying to find an LCM, at least common multiple, to cancel out. If you added the negative 5y and the positive 5y, they won't cancel out. Okay, but in this case here, because I simplified the problem, these two things right here will cancel out when I add them together. So I'm going to add everything together, and then that's going to give me 80. And then that's going to give me 2x. And then I now know that x is equal to 40. Because if I divide 2 from both sides, I come up with 40. Or I can just say 40 times 2 is 80. Okay. Now, I can take that 40 and plug it into either problem. Okay. If I plug it into the first one, 40 minus 10 will give me 30. And 40 plus 10 will give me 50. So I'll just do it right here on the side. X minus y equals 30. Okay, and then I'll put the 40 in. And then 40 minus 10 equals 30. Like that. So that means y is 10. Okay. Like that. So that means y is 10. Okay, so x is 40 and y is 10. Okay, now what I'm going to do is I'm going to go back and distribute in this problem and show you what happens if you have to eliminate x or y the other way around. So I'm going to clear this.
Wait, how did you get 10?
Well, I just said 40 minus 10 is 30. Okay, because it was x minus y equals 30. So when I put 40 in for x, then I said 40 minus what equals 30? 40 minus 10.
Okay.
Okay, so I'm going to take the same problem again, and I'm going to distribute. Okay, just to show you what happens. And then we're going to have to close out the session after I finish with this. Because I got to run across town. Okay, so we'll distribute here, and then that's going to give us a brand new equation, and what we call an equivalent equation. They're equivalent when you come up with the same answers for them, 5x minus 5y. And then we'll distribute on the other one. Three x plus 3y. Okay, now you can't cancel out either one of these the way they are, because if you say, 3 minus 5 will give you a negative 2, so that's not going to cancel it out. So what we're going to have to do is we're going to have to find the LCM between the negative 5 and the 3. And because they're both prime numbers, you can multiply it together and it'll be 15. Okay, so how do we get there? For the first one, the whole thing gets multiplied by 3. And for the second one, the whole thing gets multiplied by 5. So that's how you come up with the LCMs in this case. And then, of course, 3 times 150 like that is going to go over your 450. And then we're going to have 15x. We're going to have 15y. A negative 15y. And then 15 here is going to give us 750. And then you're going to have 15x. And then you have 15y. Now, by finding the least common multiples, and that's a fraction concept, we're going to see that we can cancel stuff out when we add these together. It's going to be a canceling out. Show you right here. See, these two things right here are going to cancel out. Okay, and then that's going to leave you with 30x down here. And then we're going to say 0, 10, carry the 1, 11, 1200. Okay, then we'll pull out the calculator on it because we'll end up having to divide both sides by 30. Okay. Sometimes you can just look at them and know what the answers are going to be. Okay, you can't, 30 times what will give you 1,200. It's not like it's on the timetable chart, so now you got to divide it out. I mean, if it's on the timetable chart, then you can look at it and you know what it is. So we're going to say, okay, we got to reverse it with division. 1,200 divided by 30, and then that'll equal 40. Okay, so now, some people may just look at that and know it, because some people can look at that and say, well, 30 times 40 is 120. Well, if you know that, then you don't have to do anything extra. Okay, now that 40 gets put back into one of these equations. Okay, so you can take it and drop it into this one right here. And then, so what you're saying is that 3 times, and then we got 40 here, plus what would equal 150? Well, we know that, 3 times 50 would equal 150. Okay, so because that's what we're looking for, 150. So we know 3 times 50 is 150. So even though we've got the 40 there, we know the other number has to be 10, because 40 plus 10 will give you 50, and then 50 times 3 will give you 150. Okay. Sometimes you can do the mental math on it once you start working through the problem. Some of the problems you got to go through these algorithms to get close enough to the numbers, because the mental math is not feasible for us. Okay. But once it becomes feasible, then, at that point you can start working with that. All right, guys, it's been great. I would ask if there are any additional questions, but unfortunately at this time I can't afford to answer them. I got to pack up and go. So there should be another session. Let me see when it's coming in. Um, Today, let's see, is it today? Today is Tuesday. No, there's not another session today. The next session is on, well, wait a minute, that's tutoring. Let me go to training. Okay, so today is Tuesday. The next section is going to be Wednesday from 9 to from 10 to 12. Is that 10 to 12 really? No, that's 9 to 11. So the next session is going to be 9 to 11 um, with, with Tracy. Okay, so you may want to hold your questions for her. Okay. Um, if need be, you can ask me questions at this. Uh, okay. You can ask me questions at tclark@fullsail.com. Okay. All right. God bless you guys. You guys have a great day. And hopefully I'll see you guys on Thursday for the go-to training. You can get in with Professor Tracy Lindsay on Wednesday night, 9 to 11 o'clock as well. All right, guys, it's been great. Got to run. You guys have a great day.
All right.